right, so the last time we met, we had a lot of 90% mastery in the quiz, but only like 2 100%. But this time you had like 600%, so that's a huge improvement. And the common error that we really zoomed in on was solving for the square root when it wasn't a perfect square. So we figured out a new way to model that, and students had a lot more success. Nearly every kid, when I was flipping through, got the question right when it involved solving for the square root when it wasn't a perfect square root. So what are the key moves you executed to ensure that success?
I think the reteach on doing a square root with like the concept of, look, the square root of a square number is like this integer that we know. That step really cleared it up for kids, and I noticed like once they got that, there were no more mistakes. There were still mistakes on factoring, but that wasn't the focus. And I think with like the long spring break, there was like some rustiness with factoring. But like I saw the same thing with the square root problems. They like were using that strategy and getting them right.
Nice. Yeah, kids were doing really great. Even like the lowest kids, the 10s and 20%, got this question number 1 right.
Which was the most missed question.
Exactly. So you also like monitored for it too, like when you did this lesson, like I circulating around, so that was a big thing too. All right, so since this is a quiz and it's over multiple standards, I'm going to dive into question 3 today. I chose question 3 because this is a question in which some students just skipped over it and went straight to number 4, so that tells me they didn't want to get started, or they didn't know how to get started. And then some students like tried to do it but clearly got stuck at a point. So this is why I chose this one, also because it incorporates a lot. So here's a perfect example of why I should focus in on this. Like Najira is a super high kiddo, but we actually looked closely. She didn't get that one wrong. Right. I mean, it's a quick thing when you were grading. And so this is like a perfect example of Najira's not getting it right. She made that one little mistake. This is a perfect question to zoom in on because it incorporates the skills that are in a lot of the questions. Okay, so before we get started, since we're zooming in on question 3, make a list of all the things kids need to know and be able to do for question 3.
Yeah, we've talked about this one. This is the one I picked out of this quiz as well. So.
What did you say? Start with either one, either the know or the do.
Starting with the do, they have to set it equal to 0, put it in standard form, factor out -1, which is where I think most of the mistakes were made, factor with the area model, and then write the factors and solve. And I looked at the same one and was really thinking the same thing. Like this step of like factoring out the -1 was not done by many people. So they need to know they cannot use inverse operations. I did see that mistake in a couple. This is like the focus of the day. That they must factor because there's a middle term, that it must equal 0 in order to factor, and that the leading coefficient should be positive. Like they need to know that. They also need to know like factoring with an area model.
Okay, so there's one thing you said that I didn't have and I added, and one thing I have that I didn't hear you say exactly. So definitely I've left out the factor out -1, which is super important. One thing I want to have you zoom in on is why is it important conceptually for the kids to use the area model?
Conceptually to use the area model, I guess understanding that like the factors multiply to give you the expression, and that's what the area model is used to like really show.
So let's take a minute and capture the purpose of the area model there. They need to know. Sorry if that's my hair.
I think it's mine.
Okay.
Sure.
So how did you capture that?
Factoring undoes the process of multiplying, which can be shown with an area model.
Okay, and what's the purpose of the area model?
To show what multiplies to give
Right.
the expression.
Write that down real quick. Area model show.
Area model shows that what multiplies to give the 4 terms in the expression.
Perfect, because this kind of goes back to an earlier misconception we know they had earlier in the year, is that these factors are like multiplication in reverse.
Right.
And kids need to understand conceptually, like, you know, procedurally we do an area model, but conceptually, like, it's because we want to see. Great. So let's take a look at your exemplar. What are the keys to the exemplar response for number 3?
Set it equal to 0, factor out -1. I didn't use the area model. When the leading coefficient is 1, and I'm teaching this to pre-algebra right now too, I would prefer kids didn't use the area model. I don't know if that's gonna, just because this should be, like, if you need to list factors of 32 to see it, do it, but
I think they're still at the point where they need to do it.
they probably are.
This is kind of like going back to like the showing the work thing, right? Of course we'd want them to do it in their head, but if they...
Yeah.
I'll show you in the student work in a minute, but they are getting stuck. Okay, so you named all the things, but let's take a look at Mrs. And what is, and I think you're gonna, like, now you just said that, what does Mrs. Exemplar have that you offer that yours does not?
Well, she uses this area model. She also did not factor out -1.
So she made her life complicated, but she did attempt to use the area model.
Yes. And the way that she factored it works.
Not the prettiest, but she used it because
Right.
the math made sense. It worked out for her.
Right.
Okay.
She ends up with this factor 16 minus x, which is tough, but she got it.
Great. So what's the procedural importance and the conceptual importance of using the area model?
Procedurally, this is gonna it's gonna help you not get stuck. It shows you what to do with your terms. And conceptually, the idea is that you're undoing what multiplied to give you that expression.
Awesome. All right, let's take a look at some medium samples of work. I have Anissa and Journey here. So what is it clear that Anissa and Journey know how to do on number 3, and then where did they get stuck?
So they know that they need to set it equal to 0.
Uh-huh.
Anissa got stuck because she didn't factor out -1, so she's multiplying to get 32 instead of -32. Journey knew to factor out -1, but then didn't. Again, she got stuck not being able to find her factors.
Right. So how might experimenting with an area model have helped them?
I mean, they could have plugged in the x-coordinate in the -32. I think this definitely goes back to one of the misconceptions we talked about before, though, of like they need to list their factors because both of them got to that point, and they can't fill in the area model until they have these two numbers.
Until they have their factors.
Right. So
Right.
they have to have those two numbers to fill in the area model.
But they could have tried it even with just like the big number of 32 and 1 and realized it was wrong because last week you modeled for them what to do when an area model is wrong. Cross it out and try a different one. So it would have been like another, it would have helped them avoid getting stuck, right? Because they clearly got to this point and then they got stuck.
Yeah.
So the area model would have helped at least them to try to figure out like the next step there. Okay, let's take a look at DeAndre, Joseph, and I forgot who the other one was, Denisha. And so these kiddos did try to do an area model, but what is the procedural gap that we see with their area models?
Didn't factor out a -1, so this actually isn't true because that would be -x². Didn't factor out a -1, and she should have added 32. He also should have added 32. So the setting equal to 0 seems to be, they did add 32 and factored out the -1, and then couldn't find the two numbers that multiplied to -32 and add to -14. So DeAndre and Denisha are having trouble setting it equal to 0 correctly.
Mm-hmm.
And Joseph just needs to start listing factors.
Right.
You could tell he tried 16 and 2, but didn't try negative 16 and 2.
Mm-hmm. So what is the procedural gap we need to close? One of the procedural gaps.
Two big things. They have to be able to set it equal to 0 and factor out negative 1. That
Let's
to me
assume
is-
they know how to set it equal to 0. Most kids actually did that. So what was the second thing you said?
Factor out negative 1.
And
That was a big game changer when we talked to kids.
So that's the first procedural. What's the second procedural?
I think listing these factors and then putting them into the area model. Like I'm still seeing, list the factors here.
Great. So I heard factor out negative 1, listing the factors to set up the area model.
Mm-hmm.
Now, what is the big conceptual misunderstanding they're having?
I don't know. I mean, we talked about the concept of like what undoes the multiplication. I don't know that is a conceptual error. I think if I was really thinking of the conceptual error, I'd be saying, a couple things like the number sense of like if this is a negative and we're multiplying, then.
Let me zoom in on the factoring. Why is the factoring important?
Oh, like listing the factors?
Mm-hmm.
Just to find these two terms?
And why? Right. So this goes back to that.
Just splitting like the linear term?
It goes back to that conceptual understanding of like why we factor and stuff like that. It all goes together. Like we're finding the factors because those are the we're doing multiplication in reverse here. It's appearing to me that they're still not clear. Like the reason why we factor and why we need this step conceptually is because we're trying to do multiplication in reverse. If they understood that we're trying to just further break this down, they wouldn't be skipping that step of factoring.
Like listing the things that would multiply to give us this number, which is what we're trying to do in the whole. Yeah, I could see that. I think that would encourage them to start listing these factors, which we've talked about before.
So if you ask kids, why do we factor here? What's the ideal response? Like, why are we factoring here?
You're finding the numbers that multiply to give you this expression.
Great.
To give us this term.
And then why do we use an area model next?
To find the expressions that multiply to give us this.
And to check our work.
Trinomial. Sure.
Okay.
Yeah.
So what is the procedural gap and what is the conceptual gap?
So procedurally, they need to factor out negative 1, and they need to list factors to set up their area model. Then conceptually, there's the gap of like you're listing these factors to undo multiplication.
Mm-hmm. And conceptually, why are we doing the area model?
To undo and find the expressions that multiply to give us the trinomial.
Awesome. Okay. So because this had a little bit lower mastery and it does incorporate so many things, I do believe you should do a model for this. So I'm going to model how I would launch it, and then I'm going to have you script out the rest and have you practice it like at least twice through.
Okay.
Sound good?
Yeah.
Okay. Before I do that, though, I want to make sure we write it down so we're clear we're stamping the right things. The procedural gap, I believe there's two we're gonna address, and then the conceptual gap we're gonna close too. Okay, real quick, I know we've said it like 3 times, but I want to make sure we root ourselves in this when we're doing our model practice. So what are those procedural gaps we're going to close? What are the conceptual?
Factor out -1, list factors to set up the area model. Conceptually, you're listing the factors to undo multiplication and using the area model to find expressions which multiply to the original trinomial.
Awesome. Okay, I'm gonna again just do the launch part and then have you think through how we're gonna stamp that in our model. Okay, so ladies and gentlemen, I want to go over question 3 from our quiz. Sorry, I'm gonna start over. Ladies and gentlemen, as you know, we had a reteach lesson on Monday, and the questions that we retaught, like number 1, you guys did great on. I want to zoom in today on a question like number 3. You've shown it, again, once again, you can do parts of it, but we need to zoom in on how to finish it, how to do the closing. So almost everyone in the room showed me that you know to set this up equal to 0. Okay? Almost everyone in the room did that. You also showed me that you knew that you need to find 2 numbers whose product equaled 32 and whose sum added to 14. Then we got stuck. Here's what you do when you get stuck when you're trying to factor.
Okay.
And what did you notice that was effective about what I just did?
So you're not like going over setting it equal to 0. You're jumping in where the gap is, and we're not like zooming in on question 1. We're like naming like, hey, we grew. I think we could even like stamp again like what we retaught, y'all mastered.
Right. Good.
It was a long spring break. We kind of forgot some of these factoring things. So like, if we're gonna get stuck, how do we undo that?
Right, and so, great. The 2 things I want to emphasize with you, and that's why I started over, was 1, celebrating our success. That's why it was so important for me to start over. And then 2, saying, and then we got stuck. So that we can acknowledge, like, it's okay to get stuck. You just got to try something. Okay, so here's a marker. Finish your scripts. And then I'm going to have you practice it at least twice.
Cool. I'm gonna change one thing on here.
Okay.
And I think, yeah. I can do this. I'm ready.
Script it real quick.
I'm gonna say these things.
Script it.
Okay.
Right.
Great. And then we got stuck. So.
Wait,
when-
start from the beginning.
Oh, okay. This Monday we did a reteach on solving quadratics with factoring and inverse operations. I just want to name that on questions like number 1, which you guys overwhelmingly got right, that's what we retaught, and almost everybody got it right. We're definitely growing and getting better. We had a long spring break. This is a tough equation to factor, and I saw number 3 being one that like most of us really got stuck on. So on number 3, almost everybody knew, hey, I need to make this equal 0. There's a middle term, I can't use inverse operations. So we're going to try to factor this, and I saw you guys say, hey, I know this has to multiply to give me negative 32 and add to 14. Then we got stuck. So, when we get stuck, what should we do? 2 big things I want to stamp. Every time this leading coefficient is negative, factor out negative 1. This is going to make it so much easier for you to factor this expression. When we factor out -1, we're left with x squared, leading coefficient positive, minus 14x minus 32. We're still looking for a number that multiplies to give us -32, but will add to give us -14. Now I'm going to start listing factors of -32. This is the step that I think is the most critical when we get stuck. If you're stuck, list the factors of -32. Why? Why do I want these factors? I'm looking for the numbers that undo multiplication. -8 and 4 undo the multiplication of 8 times 4 is 32. We're looking for the numbers that multiply to give us -32 and add to -14. -8 and 4 do not add to -14. I'm going to keep listing factors. Maybe -16 and 2. -16 times 2 is -32, and it adds to -14. Use these factors to fill in our area model. We have 4 terms. And from here, I know that y'all know how to factor out and find the expression that would multiply to give us this trinomial. We know this is going to be x minus 16 and x plus 2. Last up, solving this, almost everybody in this room knows x would be -2 and 16.
Okay, 2 things. One, not everybody did do that last step right. We didn't zoom in on it today, but I think it's important to like do the actual work for that, where you set it up.
Mm-hmm.
And then the second thing, talk about when you're doing the area model, you need to show them, like, you need to talk through your thinking steps of, I know this goes here because, I know this goes here because some students were not filling out the area model correctly.
Okay.
Okay, so let's do it again from here. So again, the key things in this next round are talk through what you're putting where in the area model and why, and then actually doing the math for this last step. But it was really effective that you stamped like factoring, I'm doing multiplication, it's okay to get stuck, so we keep going. That was super effective.
Okay.
I don't know where you're gonna put this.
I'll just put it right underneath.
Okay. So from the beginning, stamping the area model, and the last step, showing me how to do it.
Great. You guys took a quiz on Monday, and for the most part, I saw a ton of improvement on questions like number 1, using inverse operations. You guys grew a ton in like being able to simplify radicals, and I think that new strategy we have is really helping us out. Where I saw us get stuck was questions like number 3. Number 3 is tough. We had a long break, and this is a tough one to factor. So let's look at number 3. Overwhelmingly, I saw all of you able to set this equal to 0, and then say, hey, I want something that multiplies to -32 and adds to 14. And we got stuck. It makes sense to me that we got stuck here because our leading coefficient is negative. So every single time you see a negative coefficient, what I want us to always do is factor out -1. This will change from -1x squared plus 14x plus 32 to +1x squared minus 14x minus 32. I'm just dividing each of these terms by -1. Now I see, to factor this, I actually want to multiply to get -32 and add to get -14. Again, a lot of us are getting stuck because we're not able to think of the 2 numbers that multiply to give us -32. Every time you get to this point and you don't immediately recognize numbers, I want you listing the factors. So if I tried -1 and 32, that multiplies to -32, but it adds to 31. This is not correct. That's okay. Try another factor. So a lot of us try 8 and -4. That also multiplies to -32, but it adds to 4. Do we give up? No. Keep listing factors. -16 and 2 multiply to -32 and add to -14. So what should you do if you're stuck trying to find the 2 numbers that multiply to give you negative 32 and add to negative 14. Miss Niewald.
You should factor out and just check the numbers.
Yeah. Can I have you stamp that, Jamarco? What are we going to list?
We're going to list the factors of 32.
Perfect.
Because we're undoing multiplication.
Nice. From here, we're going to fill in our area model. I'm going to set this area model up, and we're just going to look exactly where each term goes. The first term always goes in the first box. The last term always goes in the last box.
Great.
First term, first box, last term, last box.
Great.
The two numbers we just found complete our area model. It does not matter which the boxes you put them in, just fill it in. Factoring undoes multiplication. So I'm looking for the numbers that multiply to give me x squared. X times x gives me x squared. I'm now looking for the number that multiplies to give me negative 16x when I multiply it by x. X times negative 16 is negative 16x. And x times something is 2x. Well, that something must be 2. Now I have my factors. X plus 2, x minus 16. Don't forget, you factored out a negative 1. Bring that on down. Last step. This equation is set up to 0 because we're trying to solve it. Go ahead and solve this by taking each factor and setting it equal to 0. X plus 2 is 0, x minus 16 is 0. Solve each of these equations using inverse operations. Box those answers.
It was really effective this time that you said it's okay to get stuck and keep going through. Also effective when you said the first term goes here, the last term goes here. It doesn't matter where you put these. And you again stamped that factoring is undoing multiplication. And again, super effective down at the bottom when you said we're solving now.
Yeah.
And did the y. How is this model in practice going to close the gap that kiddos have?
I think modeling factoring one more time after a long break, just in general, is going to knock the dust off of a lot of students. I think also when students get stuck, when it's not 8 and 4, like the first things you think of, this is going to help students break through and list factors. We really need to just get in this habit.
I also liked the second time when you modeled how you said, I can see where you got stuck. It's much easier if you factor out negative 1. That was a really sticky thing for kiddos. Okay, you can come back over here. When are you going to do this?
So we talked about one just like this today because I pulled this problem out. I can do it again.
It's worth it because it incorporates multiple things.
Yeah. Then we'll have to do it on Thursday.
Okay.
Thursday's a big day. But yeah, we'll do it Thursday.
You could shorten your do now and then do just after the do now.
Yeah.
Okay, so Thursday. Awesome. I'm going to come in then on Thursday.